Question 5. Question is, in the given figure, AD is median of triangle ABC and AM which is perpendicular to BC. Now here we have to prove these three results. Now first of all we have to prove first result. This is AC square is equals to AD square plus BC into DM plus BC divided by 2. Here we remember that AD is median of BC and AM is perpendicular to BC. And in this question, here AC square and AD square are given. That means first of all we have to use Pythagoras theorem for triangle AMC, and for second one AMD. Now proving this result, applying Pythagoras theorem on triangle AMD, this triangle AMD, Pythagoras theorem for this triangle is AD square plus AM square plus MD square, written here. Second, applying Pythagoras theorem in triangle AMC, for this triangle Pythagoras theorem is AC square is equals to AM square plus MC square. Now AC square as it is, AM square as it is, instead of MC, we can write MD plus DC whole square. Now simplify this term MD plus DC whole square. Therefore AC square is equals to AM square plus MD square plus DC square plus 2 times MD into DC. Now we know that AC square is equals to, for this result, AD square plus AM square plus MD square. Instead of AM square plus MD square, we can write here AD square plus DC square plus 2MD into DC. Next one, we know that here AD is median of BC, therefore D is a midpoint of BC. Therefore, we can write here DC is equals to BC by 2. Now we obtain here DC is equals to BC by 2. Therefore, AC square is equals to AD square. Instead of DC, we can write BC by 2, and similarly here. Now simplify these two terms. Therefore, BC square by 4 plus here 2 are cancelled. Therefore, here our result is AC square is equals to AD square plus BC square into DM plus BC by 2, hence proved. Now next result, we have to prove AB square is equals to AD square minus BC into DM plus BC by 2. Here we have AB square. Therefore, we are using Pythagoras theorem for triangle AMB, and here we have AD square. For triangle AMD, we can use Pythagoras theorem, and using these two Pythagoras theorem, we will prove our result. First, applying Pythagoras theorem on triangle AMD. Therefore, Pythagoras theorem is AD square plus AM square plus DM square. Now, applying Pythagoras theorem on triangle AMB, Pythagoras theorem is AB square is equals to AM square plus MB square. Instead of AM square, instead of am square, we can write ad square minus md square. Now, instead of mb, we can write bd minus dm. Now, simplify this term, bd minus dm square. Therefore, ab square, ad square minus md square as it is, plus bd square plus md square minus 2bd into md. Now, here minus md square and plus md square both are cancelled. Therefore, we have only ab square is equals to ad square plus bd square minus 2bd into md. Now again, we are using result md is a median of bc, therefore d is a midpoint of bc. Instead of dc, we can write bc by 2. Therefore, ab square is equals to ad square as it is. Instead of bd, we can write here bc by 2 minus 2. Instead of bd, again we can write bc by 2 into md. And hence, now simplify this, 2 cancel. Therefore, our result is prove ab square is equals to ad minus bc into dm plus bc by 2 whole square. Now, third and last result from result 1 and 2. Here we have to prove that ac square plus ab square is equals to 2ad square plus half of bc square. Earlier we are prove that two result. Using that two result, we have to prove this result. Applying Pythagoras theorem on triangle AMB. For this triangle, Pythagoras theorem is AB square is equals to AM square plus BM square. Next, applying Pythagoras theorem on triangle AMC. For this triangle, AC square is equals to AM square plus MC square. Using this two result, here value of AB square and AC square, and we have to prove that AC square plus AB square is equals to 2AD square plus half of BC square. Therefore, adding these two results, adding equation 1 and 2, we obtain here AM square plus AM square, 2AM square plus MB square plus MC square is equals to AB square plus AC square. Now, here 2AM square as it is, plus instead of MB, we can write BD minus DM. Instead of MC, we can write DM plus DC, and remaining part is as it is. Now, simplify these two terms, 2AM square, A minus B whole square, that means BD square plus DM square minus 2BD into DM. Again, here we will use this rule, A plus B whole square, MD square plus DC square plus 2MD into DC, and remaining part is as it is. Now, here we have MD square plus MD square, 2 times MD square, BD square as it is, DC square as it is. Now, in these two terms, 2BD into MD plus 2MD into DC, we have common part is 2MD. Therefore, 2MD is common, and remaining part is DC minus BD is equals to AB square plus AC square. Now, in next step, in this two term, 2 is common, AM square plus MD square. AM square plus MD square plus here BD again we will use AD is a median, therefore D is a midpoint of BC. Therefore instead of BD and DC we can write BC by 2. Therefore BD is equals to BC by 2. Here DC is equals to BC by 2. 2 times MD as it is. Instead of DC and BD we can write BC by 2, and now simplify this term. Now AM square plus MD square. Here AM square plus MD square, by Pythagoras theorem we can write AD square. Therefore here 2 times AD square plus BC square. BC square upon 4 plus BC square upon 4. That means 2 times BC square upon 4, and simplify this we get half of BC square. Plus 2 into MD. BC by 2 minus BC by 2 both are cancelled. This part is 0, and anything multiplied by 0 is equals to 0. Therefore is equals to AB square plus AC square. Now we have proved AC square plus AB square is equals to 2AD square plus half of BC square.